Hi guys, we're taking brain waves and trying to turn them into audio. Crazy, I know. We're using basically the VST instruments that I was making earlier. So we are making prime number inspired transform. We are making basically bells that are fed brain signals like EEG. And then what we are doing is we are doing the ear has or after ear the brain has this thing called cochlea that turns audio into a brain signal, and we are trying to inverse that process. So it uses something called the log transform, and we are doing inverse cochlea calculations. And you guys can see it here. Sorry guys, and here, see here are the bells. So we are ringing, taking the brain signal, the firing of the neurons, and we are turning that into this resonator, and then trying to do the inverse, and we get very speeds like ding. And so we are talking with Grok about this. And we can use sine waves, sawtooth, or hybrid to basically for these bells what they are using. And so okay, thinking. Let's take 30 seconds and let's just use the sine. And we are talking with Grok. Okay, so we're gonna try to, let's save this. So we're gonna use FL Studio here. So this was earlier one thing. So I've been doing this for a while here now. I guess I will release this with you guys. It's gonna be EEG to Audio Studio, and I'll do some sort of readme. Okay, so here's our file, and we're gonna do something called coding. So we're gonna put it to. First, let's listen to it for a while. So what I'm doing is I have here I have bit shifters, so these can actually shift the sound up or down because it's real. Brain works at under 100 hertz, which is kind of like what you would think are sub bass noise. We're gonna try to pitch it up and see what happens. And we are doing some filtering to this sounds nasty, but listen. Let's see. I'm gonna check out that we have a loop. Okay, so there's our audio, and now we are gonna put that on the right channel, and here we have vocodex, and vocodex is it's going to be vocoding that with something. So we are going to use some sound to vocode it. Here is my vocals, or we could use a synthesizer, but I think we should use white noise perhaps for some reason. But let's listen to it first a little bit. And okay, what we will do now, let's render another one. So we're going to take another EEG, and let's see. So we are hoping that the neurons somehow we can use them as sort of bells that we can backtrack via this mathematical operation, inverse cochlea operation. Let's see. So let's do the solder ones. And did we really use the electrode? Okay, D3 is where you would expect. This is where speech is. And we also we have 32 resonators. We have denoise, which is taken from the quietest part. I think we could actually do that by hand. That might be the best. Okay, there's our new one. Let's save it. Let's take clearly louder. Let's make this a bit quieter then. Let's do some audio operations. Let's take it and let's take a quieter part and use that as a. Well, let's take this one here. So we have the 32 bells. You can actually see them all the bells. However, many these lines are the resonators. So when the EEG hits them, I think that looks pretty good there. They resonate in prime frequencies, prime number inspired frequencies, and acquire noise profile, and it creates this crystal-like sound, like on the VSTs, you guys can see them here. 100%. Threshold is 0. It would be so easy to think that speech, it is the brain signal resonating with this system we made. Now let's give it a different sorts of input. So we're gonna use 3 OSC if that's still available. There's 3 OSC, so we are gonna give it different sorts of noise. So this is now just sine waves. Let's see, where did we have the volume? So there's pitch. I haven't used this in a while. This is the mix. Let's just use the first one here. So this is going to create different sorts of sound sources, and we are going to put that here. And let's. So it's going to be a sound source, and it's going to be used as a vocoding input for the sound. So you guys can actually hear this. Let's put it to another channel so hear what it sounds like. Something like that. And we could bring it all around. Now let's bring it to the a sad cliff point. I have brain damage, and for some reason my brain does that sort of sound at night. I listen to a podcast, and as of last, I don't know, 3 months. No, it has actually happened since 24 first time. Every now and then I listen to podcast, I wake up in the night, and speed sounds like that. It sounds like that kind of a creepy. There was a movie called Fear, I think, where the monsters had that sound. And for some reason, whatever decoding part of my brain goes offline, and speed sounds like that. Speech only. So it could be that we're actually hearing something that's not decoded, like the, so we're listening to the right part, temporal lobe input electrode getting recording. We are doing the neurons are firing, and we have our oscillators. They're resonating with the neurons, and then we are doing the inverse cochlear process. But that's how it sounds like when something breaks in your brain. There's a good chance because of that, if there is some sort of if you guys think AI like decoding going into the conscious mind, however that works, that's not known, that this is kind of the thing that comes before it's decoding. That's how it sounds. That's how it sounds. Exactly. But yeah, so if that's how it is, then if you guys think of AI model is trained to see that one thing is another thing, and that's exactly what might be going on in the brain, and we're actually hearing the thing that when the decoder goes offline, that is the thing. Like if you had the decoder in the brain, the AI model, not AI but neuronal model, that's decoding the whatever is coming in. This could be the cochlea, this could be kind of the cochlea, what it's bringing in, and then it hits the neurons, and the neurons are turning it into a speech. But that's a crazy theory. But anyway, so I am perhaps the one in the billion or millions who has heard that. But yeah, so I'll share this thing with you guys, and if that's true, then I guess the way to try if this is actually something real would be very simple. You would have to have a person listening sound, so you get the so-called ground zero, so you know what's in there. Then you have an EEG from temporal lobe 3, and you record this thing at the same time. Then you train the AI model with both the EEG and this creepy sound. And then you are gonna take an EEG from a person listening to speech after you have trained that model. So you, okay, here's the creepy sound, and here's the what it means, and then you are gonna try to have the AI model decode it back. And if that works, then perhaps that's how it goes. But anyway, yeah, I guess this is what I'm doing this Wappu. Well, it's gonna be a nice day, so probably not. But I'm gonna share this code with you guys, and EEG to Audio Studio, I think it's called. Yeah, EEG to Audio Studio, and I'll put some simple README on that. And any person with EEG, if you want to do that, it should be actually doable, even in a small, not a great computer. Have fun. Anyway, I hope you guys have